Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 2 to the power of n plus 8 to the power of n is equal to 68, and we will solve this problem for the values of n, for the real values of n. So the very first thing we are going to do is, here first I can rewrite this equation as, here you have 2 to the power of n, we can write it as 2 to the power of n, plus here you have 8, and now we can find the prime factors of 8, so that the prime factors of 8 are 2 to the power of 3 and its whole power n is equals to 68. After this step we will use here the nice exponential law, and you know about this law. If we have a to the power of m and its power n, it is equals to a to the power of n and its whole power m is equals to a to the power of m times of n. So now we use this nice exponential law in the second term, or this term, so that the above equation will be rewritten as 2 to the power of n plus, here I can, this exponential law just states that if you can interchange these two exponents in this form, then you will always give the same answer, which is a to the power of m times of n. So that if I can interchange these two answers, these two exponents, it cannot be affect our final answer. So that I can just interchange these two exponents here, so that we will get 2 to the power of 3 and its whole power n is equals to 68. And now we interchange these two exponents and we write 2 to the power of n and its whole cubed is equals to 68. And now we change this cubic equation into the quadratic form, or a cubic form, so that here I can put y is equals to 2 to the power of n, so that this exponential equation will becomes in cubic form, so that its cubic form is y plus, when we put here you get y cubed is equals to 68. Now we rearrange the terms and we move the term in the right hand side to the left hand side, so that we will get the output in the form of y cubed plus y minus 68 is equals to 0. So this equation will becomes in cubic form, so that now we make the factors of this nice equation, and the, so that here we need any two numbers whose product is minus 68 and whose sum is plus 1, so that here in order to find the factors I can write this plus y as minus 16y plus 17y and minus 68 is equals to 0. And now we will take here common from the first two terms and the last two terms, so that we get, when we take common y here, you get y square minus 16 plus here you take common 17 and you get y minus 4 is equals to 0. After this step I can take, or I can make some other simplification here, and you get y into, here you have y square minus 16, and we will write the 16 as 4 square plus 17 times of y minus 4 is equals to 0. So now here I can use another nice square identity, and you know about this identity. If we have a squared minus b squared, it is equals to a minus b times of a plus b, so that here we apply this nice identity and you will get the output in the form of y times of y minus 4 times of y plus 4 and plus 17 times of y minus 4 is equals to 0. So after this step, so here you see that y minus 4 be the common term from both of the terms, so that here I can take common y minus 4 and you get the remaining terms in the form of, here you have y into, here you get y plus 4, and plus here we take common y minus 4 and you get plus 17 is equals to 0. So that after this step, here we have two cases. The first case is we take y minus 4 is equal to 0, and the other case is we take y times of y plus 4 plus 17 is equals to 0. So now here first I can simplify the case number 1, or the first case, so that here you get y is equals to 4. It is the first root of the cubic equation. So now we simplify the second case, and in this case first I can multiply this y on both of the terms, and you get y squared plus 4y plus 17 is equals to 0. Here you remember one thing is that here we need only the real roots, so that now I can check this quadratic equation has real roots or not. So I can use the discriminant formula in order to check the roots of this equation. So that here we have a is equals to 1, b is equals to 4, and c is equals to 17. So the discriminant formula is delta is equals to b squared minus 4 times of ac. So that now you can just put the values of a, b and c here, and you see that the value of b is 4. So when you put here, I can write 4 square minus 4 times of 1 into 17, and 4 square is equals to 16 minus 4 times of 17 is equals to 68. And finally you have 16 minus 68 is equals to minus 52. So here you see that our discriminant delta is less than 0. So if this delta is less than 0, it means that this quadratic equation has no real root. So if this quadratic equation has no real root, so that I can rejected this case, because in this question we need only the real roots, so that we will reject this case, and I can just proceed here this case only. So that in this case we have y is equals to 4, and in the start of the question we will take y is equals to 2 to the power of n. So I can put here y is equals to 2 to the power of n, so it is equals to 2 to the power of n is equals to 4, and we can write this 4 as 2 to the power of 2, and it is equals to 2 to the power of n is equals to 2 square. And here you see that bases on both of the sides are same, so that its exponents are equal. So finally we got the value of n is equals to 2, and this is the our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.